Hello and welcome to PentaLive from Pentalog. I'm Peter Green in New York. We are bringing you the tools and techniques you need to survive and thrive in the complex world of COVID-19. Today we're going to be talking about quantum computing with André König, who is an author and investor in the quantum computing world. In a nutshell, quantum computers use a different means of getting results than your ordinary computers. We don't really need to know too much about it, except that they move so much faster than existing computers that they can solve all kinds of problems that up to now haven't really had a business case for being worth solving. Everything from predicting the weather to creating new medicines to optimizing package delivery schedules. But now quantum computing's on the edge of becoming a viable business solution. And that's what André is going to talk to us about when we're right back after this music. Welcome back to DEF CON 19 from Pentalog. I'm Peter Green in New York, and with me is André König in Miami. One quick thing before we get to André is, viewers, thank you for being here. And if you've got a question for André, please put it in the chat, and our producer, Christelle Lozeau in Brittany, will read it out on the show. So, André, let's get right to the point. What is quantum computing?
Thank you very much for having me on PentaLive. It's no DEF CON in Miami anymore. The beach just opened this morning, so we're past all of this. What is quantum computing? I have answered this question probably 1,000 times and always given a different answer because nobody has one good answer. Very famous physicist, considered the godfather of quantum computing, Richard Feynman, said, if you want to understand nature, stop thinking so goddamn classically. Basically, we all grew up academically through our schooling and professionally in a world of classical mathematics and physics, and ultimately classical software. What classical means is that everything is deterministic. It fits into an equation that ultimately spits out zeros and ones, and then people like Pentalog build amazing software and solutions around it, and we've pushed this technology extremely fast. But so many things in our world, especially in nature, getting back to Richard Feynman, aren't deterministic. They are dynamic. They are living systems. They interact. You mentioned the weather in your introduction. Predicting the weather is still extremely, extremely difficult, even for the most powerful supercomputer. And that has not so much to do with the power or the speed of a supercomputer, but with how it calculates this problem of predicting the weather, which is mathematically an optimization problem. So we're basically trying to fit a square peg through a round hole. Quantum computing based on quantum physics and quantum mechanics, which explores and describes these phenomena of weather, or how a financial portfolio behaves, how a traveling salesman problem in logistics behaves, which are all optimization or factorization problems at its root, use these laws and rules to find new answers to these questions.
So how much does an average person need to know about how it works? I mean, maybe you can just explain that there's a famous example of a spinning penny that kind of explains the concept, and then we can refer people to the Encyclopedia Britannica and move on to explaining why it's necessary for businesses to start thinking about this. So just give me a small example of the theory behind quantum computing, like the famous penny example.
And quantum computing most likely will stick into the B2B domain for many years to come. The average person or consumer doesn't need to worry much about it unless they want to play some quantum games. We have quantum Tetris that just came out, and quantum Pac-Man, which are fun. There's a quantum board game using this example of pennies, but it will remain an enterprise technology that really is very complex and requires a lot of study. The penny example that you're referring to, we now use donuts, or maybe that's just my preference, illustrates one specific feature of quantum mechanics and computing, which we call entanglement. Entanglement is the idea that one element, which we describe in a specific state as it evolves in, imagine a little bowl that we call the Hilbert space, and it can be anywhere on the surface of this sphere, this Hilbert sphere. So we describe the state of this element in a Hilbert sphere. Another element, seemingly unrelated to this first element, can be fully entangled to this first one. And now when we change the state of this element, the second one will behave accordingly. And it really is like magic. We have the math to describe it. We've done it in the lab 1,000 times. Quantum computers do it every day. We're not really sure how it works. But this goes to this example how nature and the dynamic complex systems evolve. They don't evolve in a linear 1-0 fashion. They evolve in a very complex fashion that has states of entanglement, states of superposition, where you have continuous infinite values between 0 and 1, not just 0 and 1. The third principle being the one of interference, which you're familiar with from throwing a rock into a lake and watching the circles it forms. And when you throw a second rock next to it, these circles might cancel each other out or reinforce each other to make bigger waves on the surface of the water. These are all quantum mechanic attributes that quantum computers use to be able to calculate values and data in a more representative way than binary classical systems.
So what is it that people really need to understand in business about quantum computing? How is this going to affect a business person? If you're not IBM that is building quantum computers, why do you need to know about this?
And many Fortune 500 type of companies really around the globe today are using quantum computing, and more at an experimental or learning state rather than expecting a new paradigm shifting business result from it by the end of this week. It is really about getting to know this technology. What people need to really understand is that our classical computers that we have built on discoveries, approaches, philosophies that are 50, 60, 70 years old have very natural limits that are just built into those systems. And we will not overcome those limits through sheer raw power by building bigger and bigger supercomputers. To overcome those limits, we need new tools in our toolbox. So if you work in financial services where everything is data, and data is such a complex system where you need to optimize very many variables for other variables, for example, building a financial investment portfolio, risk analysis, financial trading, you need to be thinking about quantum computing. If you work in chemistry where it's all about discovering new compounds, new materials, you need to be thinking about quantum computing. A famous example is the caffeine molecule. I'm not a coffee drinker despite being German, but the caffeine molecule is so complex that no supercomputer can calculate it. A quantum computer theoretically could calculate it in a split second. So if we're looking at new materials or new medications, new drug, new vaccines, you need to be thinking about quantum computing. Many examples across business. Large companies are working on these, and small companies need to think about how to play in this new quantum world. Do they partner up with a large company? Do they partner up with a vendor, with a consultancy, or do they really risk being disrupted?
So we're talking about things not just developing new medicines, but this could be optimizing a portfolio, right? And one example that I like that explained it to me was that if you tried to solve a complex maze, a linear computer would go one by one down every possible avenue until it came up with one where it actually got from A to B. Whereas a quantum computer would simultaneously be holding in its head all the possible combinations and possibilities. And so you would get this response much, much faster. And then I guess if you apply that to, say, portfolio management, you can game out every possible scenario of every stock in your portfolio under every economic condition or business condition. So I'm a portfolio manager, not at JP Morgan, which I think is developing its own quantum computing, but on my own. Will I have access to this on something like a Google platform or a Microsoft platform or an AWS type platform where I can just say, okay, this is what I want to do. I hire a consultant who knows how to transform what I'm doing into quantum, and then be able to run this and keep coming up with my answers, kind of thing?
There are vendors out there that are looking to put quantum computers on premise. One of the first was sold last week in Finland, Europe, for 23 million euros, I believe. And you need a really cool, dark, silent room to host that quantum computer. Also, a lot of vendors that are working on building, think of it as a universal quantum computer, similar to universal artificial intelligence, this perfect machine. But you don't need to wait for that, and you don't need to spend the 20 million euros and have this really dark, cold room. Keep that for your beer. Today already, you can go into the IBM Cloud. You can go into Microsoft Azure. There's a handful of cloud offerings and providers that offer access to real quantum computers. IBM has 18 of them in the cloud that are distributed all over the world, in the US and Europe and Japan and so forth. There are quantum compilers, quantum software. There are quantum libraries and templates with use cases of a financial portfolio. And just to be clear, nobody today has solved this perfect, optimal, completely rebalanced financial portfolio. You mentioned JP Morgan, they are absolutely working on that. But people have written the math, people have written the software, people are making these experiments and they're getting used to this new mindset and these new opportunities and new threats as well. So you can do that today. IBM offers a free layer to sign up and play around with. It is quite fun. It's a gate type of software, just as classical software. You have CNOT gates, Hardmore gates, and so forth. It's very easy to learn. You can download a template, a library, and play around with it.
And so this really democratizes the whole concept of quantum computing. I mean, there will be these big quantum computers out there somewhere in a server shed in Iceland or something running on geothermal energy and natural cooling. And I'll be sitting at my desk with my portfolios and my clients, and this is what I want to do, send it off, and it'll start generating or automatically rebalancing my portfolios for me, or calculating the best routes for my, UPS shipping department or something like that. Is that the...
And it's absolutely stunning to me. I have 3 businesses in quantum computing. One of them, Interference Advisors, is the garden of quantum, where for the last few years I've collected data on the ecosystem, who the vendors are, the technology, investors, use cases, and so forth. 5 years ago, you didn't have much. IBM had some efforts, a few others were playing around. Today, you have over 300 quantum computing companies in the world. Some building these crazy machines that might take another 20 years to come to fruition and utter in a science fiction-like future. Others like IBM and Honeywell and Microsoft and Rigetti that today offer it in the cloud with a full ecosystem of partners, of professional services, consulting, of software, and of libraries. So all of this has been built over the last 5 years, and it is stunning to me how easy and fast the access for anybody is, which is largely due to it being a national security concern as well. All the big countries, the US, Russia, China, have poured billions and billions into this. Europe, over the last 6 weeks alone, has invested over 4 billion between the EU, France, and Germany into quantum computing at the national level. So it is a tremendously fast-growing technology that anybody should experiment with. It's also fun. It's fun to use a quantum computer and try to wrap your head around what a state of superposition, Schrödinger's cat, is she alive or dead, actually looks like.
Right, that's the whole concept, that until you actually look at something or need to define it, it exists in multiple states at the same time, right? Alive, dead, or any other place in between, which is still very difficult for me to wrap my head around. But I guess
it makes no sense, absolutely. But once you once you touch it and experience it and build with it, it really changes your perspective. Probably the longer I try to explain quantum computing to you, the more of our viewers will look like, what is this guy talking about? This is crazy. Yeah. Einstein called it spooky. Go into the IBM Cloud, go into Microsoft Azure, go to Rigetti Cloud Quantum Computing, and play with it. And you will really see how this polynomial scaling of power enables you to find answers to problems that so far you haven't been able to find.
Wow. Let me just again ask our audience, if you've got questions, please, for André, send them in. Christelle will read them out. So, André, what's the time frame for this? When do we expect to see quantum computing starting to really move into the real world?
That's the $1 trillion question. I was speaking on a panel at a 50,000 people conference yesterday with the head of
Zoom is amazing.
Yes.
You could never have done that in real life.
PentaLive, I'm sure.
Close.
With the head of the IBM program, the head of the Honeywell program, and the head of a company called Cambridge Quantum Computing, which is arguably the largest quantum startup out there. And we were asked that question. The Honeywell guy, and Honeywell just literally last week released their quantum computing program, said within 18 months. Within 18 months, we will start to see results that businesses will be able to take and implement into their core processes that aren't practical to develop and deploy on their supercomputer or any other mean. IBM pushed back on that. IBM, and we call it the NISQ era, the noisy intermediate scale area of quantum computing, where these machines are still noisy. They're not very stable. They have a lot of errors. We struggle to observe Schrödinger's cat, and by observing her, we change her state. They said probably closer to 5 to 10 years. I said 3 years, and many different opinions out there. Denise from Cambridge Quantum Computing also said 5 to 10 years. So expert opinion diverges. Nobody knows. What we have observed that over the last 10 years, scientific progress, but also business progress, has always been ahead of expectations. And with companies like Honeywell, like Intel, like BMW in Germany, or Airbus and France getting into quantum computing, industrializing its application, it will only speed up.
Wow. So businesses obviously, I mean, they've got to start pretty soon getting off the sidelines and thinking about this. How do they do that? How do you bring this, into a company, the concept that you've got to embrace quantum computing? How do you even begin to explain that both to the C-suite or the board that makes your funding decisions, but also to people across the company that they've got to rethink how they're working because all their calculations and things and stuff they might have just decided to avoid actually calculating or computing or using real data for will have to do it because the opportunity's there, and if you don't do it, your competitor will do it and eat your lunch. So how do you get that across to people in a company, and who needs to get it across?
Quantum believers like myself and many other people a lot smarter than I believe that quantum computing will be disruptive, potentially a winner-take-all type of technology, unlike AI, digital blockchain, where you start with an MVP, hope to deliver 5, 10, 15% improvement, iterate from there in an agile method, a quantum computer will either be able to predict the weather or not, build a financial portfolio or not, optimize the FedEx delivery routes or not. It is not going to be an incremental improvement. So the most important thing anybody can do, in my opinion, is to be ready when we get the starting shot. When that phone call, that press release from IBM, from Honeywell, from Google, from Microsoft, anywhere in the next 18 to 3 months to 3 years comes out saying, we have built a computer that is able to deliver that. You have to be ready that day with your team. So you need to be able to understand what kind of resources it takes, quantum developers, quantum quants, people that write algorithms, a way to describe your specific use case mathematically within quantum physics, analysts, business people, and so forth. You need to be able to integrate it into your processes. You need to be able to implement it within your legacy IT, because quantum computing doesn't replace any of your legacy. It just complements certain aspects of it. And you need to understand what your revenue model around it is, and how you bring it to market. So all of these things is something that a company really needs to get started with today and be ready in 6 months, 12 months, 18 months to deploy, when that phone rings and we have that supreme quantum computer. So start learning about it, and it takes time, it takes practice. It's a different way of thinking that is spooky, as Einstein said, and you need to invest into it. So put a team together, do a training. There are free resources on ibm.com/quantum computing, for example, but many others. Feel free to reach out to me and Pentalog. We can orient you to workshops, to trainings, both on the business side and on the software side. And I think that is really important. You need to follow both tracks.
So is there a sort of minimum size before a company needs to think about getting involved with quantum computing? Are we just talking sort of Fortune 500 companies, or is it many others who are going to find themselves needing this?
I think there are two answers to that question. First, ask yourself, is my core process part of some sort of mathematical optimization or factorization problem, which is this class of problems called NP-hard that we believe quantum computers will be able to disrupt. And you can Google that, you'll get a lot of great graphics, or reach out to us and we'll help you analyze that. But if you're in one of those industries, you need to get on it, no matter your size. And with it being available in the cloud, it is easy enough to do today. If you're a company in a very data-intensive business, my answer would be the same. No matter your size, if your survival or your success depends on any sort of data set that you collect, store, search, filter, analyze, distribute, you ultimately need to look at quantum computing sooner rather than later. Because at the end of the day, something like machine learning, a neural network, is another optimization problem. And quantum machine learning, quantum AI, is one of the biggest applications out there pursued by Google, for example. So if one of those two things rings true for you, no matter your size, you have to look at quantum computing.
And are there enough people out there, and will there be enough machines out there, enough people to guide you and enough machines out there to work on at the beginning? Or is it really going to be, the first 5 people to get quantum computers are just going to rule the world and not let anyone else have them?
I'm afraid so. If you look at some of these vendors that build on-premise hardware, like IQM out of Finland and Germany, they have limited capacity to build physical devices. These are still extremely complicated and sensitive machines to build. If you're somebody like IBM, Honeywell, offering a cloud service, every job needs to be queued. How do I prioritize these jobs in my queue? If all of a sudden JP Morgan comes to me and offers me $5 million, do I deprioritize the Pentalog job in the queue or not?
Yeah.
And these are decisions that these vendors are starting to make today. So building these partnerships and building your own understanding and expertise is extremely critical. Again, once we get the starting shot, it's too late. You need to get into the race today. Resources are extremely scarce. Folks who understand quantum and what it means for software, for technology, for enterprise processes, it just takes a few years of practice and training, and making mistakes are very, very rare in the market.
And it's easy to build classical interfaces for this, right? So that the data can be generated and then used by people down in your organization who don't need to be retrained to yet another interface or retrained to even understand what they're getting, right? I mean, your FedEx dispatcher will still get, the computer will just, he'll enter where all the packages go and how big they are, or the computer will enter that, and the dispatcher will just get a printout that says, okay, truck 37, these are your stops and how much time you have to make each one.
Most likely you're going to have your own internal quantum task force. They will need to learn how to use a quantum computer, a quantum software, and there is an increasing number of also very visually driven user interfaces on the programming side out there. There are Python-based quantum software languages out there to make this as easy as possible. You need a quantum PhD math team, and that can be one person or a handful of people that translate your business problems into quantum math. But anything else that comes in on one side and comes out on the other side is classical. It's going to be zeros and ones that you feed into your CRM, into your ERP, and your BI system, anything else, and you just need to understand how to act on it.
And does there need to be constant quantum maintenance, or is it, we create a program in quantum for, say, again, optimize